Good afternoon. My name is Will Hernandez. I've been with the Rhode Island Department of Transportation for close to 30 years, and I currently serve as the managing engineer for the construction management group. In my time with the department, I've had the opportunity to oversee many, many interesting jobs. For example, the explosive demolition of the Jamestown Bridge, the Cliff Walk, the reconstruction of Bellevue Avenue, and the Sekonic River Bridge. Little side story on the Jamestown Bridge. I was with my family at the airport. We were taking a trip, and as we were going through security, I was just having a normal conversation with the officer when my son decided to yell, "Daddy, tell him you blew up the bridge." And all eyes were on us, and you could hear a pin fall. But that's just one of those stories. Okay. The Sekonic River Bridge was built to replace the old stone bridge that was destroyed by Hurricane Carol in 1954. With a price tag of $163,677,992, the replacement of the Sekonic River project was the biggest single award project for the Rhode Island Department of Transportation. This project had quite a few unique features. The first one was the use of what was advertised back then as the biggest pile hammer in the world. It was a Bruce hammer with a driving capacity of 443 foot-pounds, and it was built specifically for this bridge, for this project. The other was the use of the 72-inch diameter steel pipe piles. In addition to that, there was a 2 3/4-inch plate, which was commonly referred to as a donut, that was welded to the bottom 40 feet from the tip of the pile. This was something to help arrive capacity. And the next big thing, which is what my topic is about, is contractor perform quality control. But before we get to that, let's just talk a little bit about the pile. To the left here is a photo of the donut, and the welder decided putting it in place. Again, this was something that RIDOT did a test pile projects, quite a few of them on the Portsmouth side, to determine what was the best method of supporting this bridge. And we tried everything from H piles to 48-inch piles to Joe shafts, and basically for the center of the bridge and the deepest portion, the 72-inch pipe piles with this donut was the best way to go, and what we did. To the right is an automated welding machine, which was kind of a unique device that was out there. Basically, the sections came in, I believe it was 25-foot sections, and to put them together, this machine would be hooked up device, and it would just simply spin around the pile, and then take it 3 days to complete the weld. This is a diagram of the layout. Piers 4, 5, and 6 were where we used the 72-inch pipe piles. The rest were H piles. And again, 5 and 6 was the center channel. The average depth of the pipe piles is around 160 feet deep. Here's a little plan view. As you can see, on pier number 7 there, we used 153 H piles compared to simply 10 pipe piles for piers 4, 5, and 6. If you take a look at the layout of the pipe piles, is each end of the pier is like a domino, with the 5 number. The center pile, the dark one here, was what we call the pilot pile. And that was the one that was used to determine to where we reach capacity. So we knew, yes?
Laser pointer? Laser pointer.
That was someone? Oh, thank you. How's it work? Good?
The button, right there.
There you go. Okay, so these two right here were our pilot piles. And basically, those were the first ones that had to be driven and that had to reach capacity. And then from that, we were able to drive the remaining piles. It was quite a project. Again, very interesting. A lot of fun to be involved with. This is a simple view of the pictures. Pier 7 over there with the H piles, and here are the pipe piles. And again, that, oh, there are your pilot piles, one hiding back there. my talk. Contractor perform quality control, something that I'm just can't speak enough about because it's so important. But in reality, what is the first thing that comes to your mind when you think of giving the contractor total responsibility for contractor control, quality control? I mean, the very first thing that came to my mind and others is, are we putting the fox in charge of watching the henhouse? And from this project and from experience from other states, this was really a misconception. A lot of people thought, whoa, contractors are going to jump all over this. You know, this is ideal. They're going to get to watch over themselves. But in reality, they didn't want it. And the basic reason was state transportation agencies across the country were always assuming the responsibility of out there actually performing the quality control. And though you would talk to them and everybody would say, no, quality control is a contract responsibility and we do acceptance. But when you go out to the job site, there was never a contractor person out there taking any kind of testing. All that testing was being performed at the plant. Once the concrete left the plant or the asphalt left the plant, what happened from point A to point B, how it was placed, it was our people out there. All my resident engineers at one point were assigned air meters, slump cones, and cylinders so they could make cylinders, all right? Concrete truck would show up, it would be too soupy, they would inform the driver would call the plant, and they tweak the mix. That's quality control. That's us performing quality control. So we're getting away from that. And one of the things that was surprisingly is that now the contractors are actually embracing quality control. You see, when you're a big contractor, quality control is expensive to get going. But once you do get it going, it's a money-making thing. I mean, contractors and big companies were, you know, when you're making concrete, you know, throw a little extra cement to make sure you make the thing and throw a little, now they're fine-tuning things. So they're not wasting the extra cement. I mean, all this is cost savings. When you figure the cost of a little extra cement here and there on a daily basis for years and years, this is a lot of money. I had one tester who once told me, he says, when I leave my job, I'm just going to go do quality control for a plant and show them how I can save $1 million a year. And it's just by simply having control of your product. Well, as with everybody else, when this first contractor performed quality control project came out, we were all kind of leery about this. So RIDOT did a lot of work, a lot of research, meeting with other state agencies saying, okay, you know, what do we need to put together to make sure this works? And we put together basically a guideline. And one of the first things that was critical was the contractor had to submit to us a quality control plan. I mean, we know what we wanted, but we weren't going to tell them, we weren't going to, you submit the plan, and it had to be approved. At a minimum, the plan had to say the minimum testing that we're going to be performed for work on items throughout the project. At a minimum, it had to have a quality control organizational chart. Who was responsible for what? It had to have the licenses, certifications, everything had to be spelled out and detailed. And what was really important that we noticed was a plan is only as good as it is understood, as it is implemented, and as it is enforced. So we basically made sure that it was a team effort. Everybody had to have a thorough understanding of this plan. On site, there had to be enough people to actually carry through with the plan. And as we go on, we'll see that it didn't all work out that way at first. This is just a little overview. As you can see, that's a quality control manager. And then there's a manager for the hot mix asphalt, concrete, and then you got here on the right, it's a manager of the plan itself. And someone underneath him, so when he's not there, so it's not the foreman of the job doing this. And what's key is, underneath that is all field testing, placement. That is so crucial. We never had that. Again, it was our guys out there in the field doing these things. And anytime we did anything in the field, we were actually taking responsibility. And when we called and said, this truck has too much water, or it's the slumps out thing, or there's not enough air, they tweak it over there. But what happened to the 5 or 6 trucks before that we mixed, or the 10 that are already on the road? It's quality. Now the contractor has to go on the site. And it was truly amazing in Sekonic, because we could have 10 trucks lined up, maybe 20. And our acceptance crew go pick number 5, and if that flunked, well, everything else was gone. They just turned around and left. It was the kind of thing, a contractor would turn around, look at his QC and say, you're responsible. Contractor had somebody who he could hold responsible, not the state. So it really worked well. But we had our problems. The first problems that we started counting is that we just had different readings. We would get their readings and our state readings would be different. And the problem with that is Sekonic has such a variance in soil throughout. It could be 10 feet apart and you get different readings. So basically communication, working together with this team and taking split samples, sharing test results, working together. That resolved that problem pretty quick. And one of the biggest things is there was so much work going on the land, in the water, steel on the side, drainage work. There was just so much testing that we soon found out the contractors' people needed more help. They couldn't give us the results on material because they just couldn't process it fast enough. And what happened is there was a contractual requirement that material could not leave that site. You had to use what was there. So we were creating stockpiles throughout the whole project. And until the results came back from that stockpile, whether it was usable, soil, ground, whatever, they couldn't use it. And it was quickly, very evident labeled, not usable, not ready, not approved. So they had to beef up their people in the plant. They had to beef up their people in the field. They had to take responsibility for the quality. They wanted to set the pace. They had to keep up the people. It was truly amazing. Now, as it should be, and as it wasn't before, but there was a lot more quality control testing than there is acceptance. So we were getting a lot of slips from them saying, hey, gravel's good, and our guys were like, okay. Again, a little leery, because now, before it was our state guys that were telling us, that pile's good, it's gravel, use it. Now it's them telling us that. So my guys I could tell there was a little problem going on, so we got together and said, okay, how can we resolve this? And basically we said, we have guys on the field, we have our materials here, let's take as many tests as they can, and let's just start comparing data. Because at first, the only thing we had to compare was acceptance. And again, there's a lot more QC testing than there is acceptance testing. So we just started taking a bunch of extra tests, and they were just for verification purposes. And I give my guys so much credit in the field, because through these tests, they started compiling and using control charts on their own. And it was just something that we just started doing. And it basically, it was amazing, because it showed that our data compared to theirs was within control. It not only showed that we were within the established contractual limits, but statistically, from a 95%, we were there. We were with them. And when things were going a little bit off, we saw it as well as did. And through constant communication with QC, it all worked so well. We did it only for concrete. I mean, there was other testing going on, but we focused on concrete because that was pretty much one of the bulk of our work. We did it for air, temperature, and slump. And I think we had like a total of 80 readings, where they had, maybe 2 or 3 more times than that. But when we did it together, these are the charts we compiled. And again, it worked well. These are our guys working together on the field. Again, this was just an ongoing process. And this was the final product, which is the way it is right now. The old bridge is still in place. As you can see, the new bridges are close to 600 feet shorter than the existing bridge. And that was because we we used MSC walls on the Tiverton side. And it was a significant savings. Instead of using a lot of piers or online, they used these MSC walls, and quite beautiful, very decorative. The town loved it, and it looks so much better than these old piers just sitting on land where everybody starts hanging out. It was really made the final product something really nice to look at. And this is what it's going to look like when we remove the old bridge. Lessons learned. Well, quality control is and always should be the responsibility of the contractor. The contractors, they're responsible for their own products. And really, they're the ones that are in more control to make the improvements. What's key is a good quality control plan, but again, it's also a good understanding of it, a good implementation of it, and by all means, an enforcement of it. The minute you start slacking off on it, it's just like everything else. It doesn't work. We also basically understand and believe that when you properly implement this, contractor perform quality control can improve the contractor's work performance and help relieve the state's burden for inspection. Most state transportation agencies are downsizing, can't afford what they used to. The money's just not there. And my personal opinion is as we move forward with this, through statistical analysis of contractor performed data, the state could start taking even less on the acceptance. It's just down the path. Some agencies are trying it already. It's just something that, if you can statistically verify it, if you have the documentation to support, it's just something that could consider and help the states down the road. And we also need to take a look at our specifications. A lot of our specifications basically are gonna pay the contractor, it's good or it pass. We wanna start looking more performance-based specifications. We want the contractor to strive to improve his product. We want them to try to give us the best possible quality. Quality typically goes hand in hand with a structure that's longer lasting. So we want to strive for that, and if we're just going to pay the contractor, X amount for it's good or it's bad, then you're going to just get that. And you want them to try to work hard to give you a much better product. And that's my presentation. I'm sorry you didn't have the notes, but I hope I was able to fill in.
Thank you.
Any questions?